So I mentioned that we're going to write a helper function that checks if the price from the Oracle and the price from the swap platform are within 5% of each other or 3%, whatever. Um, you might, I'm going to write the function, but remember that Solidity doesn't support like fractional numbers. So we need to use some math relationships to model it. Now, what we want to know is the absolute difference between A and B should be such that whatever the difference is, if you if you find the difference to like what this value is, it should be less than or equal to 0.005, which is 5%. So imagine this is A and B are equal. So this is 10 minus 10 divided by 10. So this is 0. 0 over 10 is less than or equal to this, so it's fine. So imagine if this is 10 minus 8. Okay, that's 2. Okay, no, 10 minus 9. That's 1 over 10. 1 over 10 is 0.1. Is 0.1 less than or equal to this? It is not. So it means that that difference is too great. So if you have 100 minus 99, so you have 1 divided by 100, which is 0.01. So 0.01, is it less than or equal to 0.05? Yes. In that case, allow it. So we don't want there to be a big difference between our Oracle price and our swap price. So we're going to model this thing. Now, obviously, to model it, because we can do some functions like complex arithmetic in Solidity, what we do is we move A to this side so that A multiplies this side. So you have the mod of A minus B is less than or equal to 0.05 times A. Now, remember, we can't represent this effectively in Solidity. So what we do is multiply both sides by 100. So this becomes 100 times this, then 5 times A. So we're going to then do it in code. All right. So let's implement it in code now. Yeah, so let's come to our market support library. So the function we want, let me just format all this a bit. Cool. So the function we want is we want to check if two prices are within 5%, okay? Within 5%, all right? And we need price A and price B. So uint 256, let's say price A, uint 256, price B. This is internal pure returns boolean. Okay. Now the very first thing is if any of the prices is 0, then no point. Okay. I think I showed you that in the example. Dividing 0 by something or 0 by anything, or it's mostly either infinity or 0, so we don't handle that. It means that the differential is so great, we might as well just exit immediately. So if price A is equal to 0 or price B is equal to 0, just return false. Don't waste my time. All right. Now, let's get the absolute difference. So uint 256 is the difference is equal to, if price A is greater than price B, then do price A minus price A minus price B. Otherwise, do price B minus price A. All right, good. Now, another thing we should handle is if price A is equal to price B, return true. Right? There's no use for that because it's going to be the same, right? Now, lastly, so what we are returning is return within 5%. Why 5%? Return is within 5%, which is a boolean, and that's the difference multiplied by, difference is the mod multiplied by 100, okay? And if it is less than or equal to the denominator, which is price A, multiplied by 5. Done. No. So is this undeclared identifier? Okay, let me do it this way. Cool. Yeah, that solves my problem. So we're then gonna use this, yeah? So we're gonna call this. So we're gonna get the price from the oracle, and then we're gonna get the price from this, and then we're gonna call this, and then if it's fine, everything is a go. So the first thing is, let's get the UN256 oracle price. All right. What is it? How do we do that again? We call fetch price from Pyth. What does that take in? It takes in where is it? Dun. This baby boy. Okay. One. And it says Pyth update data. Okay. And the next thing is the, what's it called? Token address, collateral token. Done. So it gives us the oracle price. Let's get the UN256. Let's get the Uniswap price. Now Uniswap has a method. I think Uniswap has an SDK. Let me double check this. npm Uniswap. Yeah. So I wonder which of these Uniswap contracts I'm going to use. If it's core. Okay, so this is V3 pool. Let me just confirm. So I'm relying heavily on Cloud for this. Cloud says I need Uniswap V3 factory, or let me see. It says I need quota. Let me see. Which library can I install to get Uniswap quota and factory for V3? I need to be sure. Okay, so I need both the V3 core, which is this one, and I need the other one, which is also got periphery. So let me install this first. The next one that I need is Uniswap. This one as well. Okay. Both of them. Okay. Then from V3 core, I get the factory. From periphery, I get the quota. Okay. So let's just copy this, yeah? Come all the way to the top. Okay. 1 and 2. Oh man, I've messed up my my liquidate loan again. Let me see. Come here. Fixed. All right. Yeah. So yeah. So we need this. Um, let's get these objects in because we're going to use these three objects. I mean, I think we will. And let's get them in. Okay, stop. Then we are also going to, of course, we're going to change the addresses for this. Well, let's form the objects first. Okay. So factory swap quota. Let's come to our constructor. Similarly, let's do this. Escape. All right, cool. So we have this check and updates, all of this. Okay. Cool. All right. So now we're going to call this quota on basically we're going to call the quota like this here. So the quota says it takes in this is what it takes in. It has this function called quote exact input single, which tells you the price of the asset. So the idea is if one of your assets is wrapped Ethereum and the second asset is so the assets that you want the price of is wrapped Ethereum, and then the second asset stable is the stable coin, which is token in and token out. So you want the price of token out. So you want the price of wrapped Ethereum in USDC. So what you do is you pass in their addresses, and for a single amount, a unit, you call the this is a fee tier. So this just says I think the fee tier is you use 0.3% for variable assets, and then this is I don't know what this last one is. I think this last one is your price square root thingy, but you don't need this. It's 0. And then you call it like this, and then when you call it like this, you get the USDC value out, and then you can compare. So what we are going to do now is we are going to do something like this here. Okay. And let's go to our liquidate function. We are going to do this. Okay. Now obviously it doesn't know what WEF is, doesn't know what this is. So for this one, we say address stable asset. For this one, this is our collateral token. So this is our stable token. This is our collateral token, yeah? So this becomes this, you know. It says quota run count for expected. What do you mean? Oh my goodness. And this is the problem that I have dealing with libraries, you know. Quote exact input in. So we're trying to see returns the amount of alpha and exact simple. So I'm looking for I see. I need this struct. So I need to make it into a struct. Token in, token out. Okay, so let's go back to the market. So it's not wrong. It's just not defined as a struct. We need to get the name of the struct. What's the name of the struct? This. So we're going to do something like this. We're going to say, we're going to wrap this in a bracket, and we're going to say this. Boom. It's going to say, obviously I can find this. So I'm going to, can it import this? Because now I'm using a library. Can I say quota dot not visible? What do you mean it's not visible? So I need this struct. So the way for me to get this struct, since it's not giving me, I'm just gonna have to make it. All right. So let's make it here. All right. And then I import it. Let's go back down. Invalid argument type. Implicit conversion from struct memory. It says this should not be the case. Okay, you know what I'm going to do? I'm going to take all of this X, all right? Then I'm also going to comment this out. I'm going to make something in memory because if I look at this, it's in memory. So let's make something in memory. So let me call it quote input, yeah? Quote memory. Let's call it quote params, okay? And we define it like this. This works. Then we come here and then we pass in the params, quote params like this. Why is this still saying invalid implicit conversion from structs memory? I'm not, it is. Okay, you know what? I need to figure this out. I'll stop the video, figure it out, and come back. Yeah, so let me just make this format so you can see it properly. So I figured out what was wrong. Apparently I don't need this, okay? If I come to take me there, okay, let's come liquidate loan. Okay, cool. All right, so we're here. So what I should have done is I should have called the I quota v2, which is this, and I should have called it in this manner. I should have passed in I quota v2 dot, you know what, let me write it myself. So first of all, I need this stuff, okay, and I'm just going to put it here so I can read it. All right, now I'm going to delete everything here. All right, so what are we trying to do? So we should use the I quota v2 dot what's it called again? This, we should do something like this in memory. We should call it quote params. Let's mute this as well. And then we should say I quota, which is this, I quota v2 dot so what we want is quote exact single params. This, we want the struct. This is what I should have done. I don't know, for some weird reason it wasn't coming out. What's the difference? Inputs, yeah. And then for each field, token in, we use collateral token. For token out, we use address stable asset. Amount in is obviously quoted 1 ether, so I'm just gonna copy this from there. I mean, we can copy everything, but I'd rather type it in, you know, because you remember better when you type stuff in, yeah? And then square root of this stuff, it's just a placeholder. You don't need it. So is this complete? Yes, this is complete. Then we call it like so. Oh yeah, we need to. So this is quota. So we're quoting, we make this parameter, and then we then call it with this, saying quotes.quota, call code params. Remember, quota has been formed here. This is it. So, and it returns a bunch of values. Let's see what it returns. It returns amount out, this after, this, and then basically what we want is we want this value. This is the value that we want, not this value, okay? It says the square root of the price of the pool after the swap, okay? The amount of token out, yeah. So because it's in stable coin, the amount of that comes out is equal to our price, you know? If it were not in stable coin, it's going to be a bit different. We're going to have to use the second variable for the calculation. Like we'll be using this one, not this one. But because it's in stable coin, everything maps to 1, so it's fine. So we get the price of 1 token of it. Now, in order for this swap to execute, we require that market I don't know why this thing is not helping me. Like, we require that market supports library dot. It should be helping me. It's just doing nothing. But within 5% for Oracle price and price for 1 token must be true. Otherwise, price deviation too large. And the crazy thing is, I've restarted my laptop, but it's still slow. It's the strangest thing. I don't understand why it's still slow. I don't know if VS Code might have a problem. I might need to reinstall some of my helpers. Anyway, yeah, so this is the condition. Once this is true, then finish the swap. It means everything is fine. So yeah, we've been messing around with the Uniswap a lot. So now we're just going to actually execute the swap. Okay. So let's go to I don't want quotes. I want something else. Yeah. This is quotes. I don't want the quotes. I want to swap with auto slippage. This is what I want. Yes, this is what I'm looking for. So basically, I want to provide the collateral token, the USDC, the amount of collateral token, the pool fee, and the slippage that I'm willing to accept, which is, in my case, I'm accepting a slippage of, even though I use 5%, even though I use 5%, I want my slippage to be far less. So we're going to be doing slippages of around, I think, 1% slippage is good, or maybe 3%, so 300, yeah. So it says here that what we need to do is we've called this expected out. We already know it. We want to get the minimum out. So to get minimum out, we need to run like a slippage calculation, which is basically checking how much slippage are we willing to accept. So here, this is 10,000 minus, say, 100 divided by 10,000. So that's a really small amount. So I think that's going to be, so it's kind of like the range that we just did. So 10,000 minus 100 that's going to be about 9,900. So this will be about 9,900 off the price. So we are only willing to lose just about 1%. Yeah. So this is the next thing that we need to calculate. So we know what this is going to be. We know what this is going to be. We know what slippage are we setting. So typically, I would say sometimes you need to be careful with slippage. You need to make sure that you set enough slippage to facilitate your swap. Otherwise, you might not be able to liquidate that position. So you want your slippage to be a bit generous, to be fair, so you don't lose everything. So I'm going to set my slippage to 500, okay, and slippage BPS. So it's going to be 500, yeah. So but we don't have like something for slippage. So let's do this. Let's go to the top. Let's create slippage here. Uint 256 public. And you can have slippage per asset as well. Well, for this one, of course, we're only going to do a single asset. I'm going to do a single slippage. So this is slippage per asset. Oh, sorry, this is just slippage. Let's just call it slippage, all right? When I change it, eventually it's going to be slippage per asset. So at the start, we set slippage to 500, okay? And then we come to, which is 5%, because 100 basis points is 100. Obviously, you should also write a function for slippage, so come here and do something like function set slippage, and then when you call set slippage, it's external. Obviously, only the admin should call this function as well. I'm not sure we've started putting access controls. We haven't added that yet. We will. We're gonna add access controls, but we're not doing that at the moment, I think. Yeah, why not? Okay. So the slippage should be uint 256 slippage, and it should set slippage, okay? And the slippage should be slippage, okay? And we require slippage that you're setting to be greater than 99, or slippage should be less than, this is less than or equal to 500, exceeds range. Okay. All right, cool. Okay. Now we have slippage. Oh my God, it's so slow. Let's come back to our liquidate function. So we're here now. So now we've already called quote exact input price. We have our quantity that should be out. So now we're going to call this, okay? So technically here we'll be using we'll be calling iSwap router. Is that what I'm using? Let me just confirm. Yeah, swap router. So for this one, we'll be calling swap router. So let's go back. We'll be calling swap router here, okay? And swap router is going to take in an object that looks like this, which is token in, token out. Okay, so now we need to use we need to calculate our slippage first. So obviously this is going to have issues. So we need to do uint 256 minimum quantity out is equal to the, so let's do this first. So the 10,000 minus 500. So we do 10,000. 10,000 is equal to, if you divide it by 100, it's 100%. That's why it's 10,000. So 10,000 minus 500, okay, which is some large amount. Now we're going to multiply that value by expected output. So this value multiplied by price of token one token, okay. So the price of one token, I think so, yeah. I'll stop that. And then this gets, if I recall correctly, divided by 100%. Now, because all those numbers are within the same denomination, we don't need to do any weird, big maths, scale up, scale down thing. Everything it is fine. We get the minimum quantity out, and once we get the minimum quantity out, we can then say swap router should have. So for swap router, we're going to now call in an object in here. So essentially we're going to say this object, which is first field is token in and token out. So we can just say token in is, we can use its value in memory. Actually, we can use collateral token. Token in is collateral token. Token out is this. Amount in. So now this amount in is no longer the price. Hold on one second. So there is something that I need to check here. So this is the price of one token, but we have more than one token. So this entire thing needs to be multiplied by, the quantity that we need. So what I'm going to do is I'm going to rewrite this. So the minimum quantity out. Okay, let me rewrite it. So let me try something. So uint. So let's assume I need to know the expected amount of collateral tokens I'm going to get out. So let's do uint 256 expected USD expected stable out. Okay. And we know the price of one token, right? The price of one token, we know it. But the quantity of the token is this. Collateral token quantity. So this price times quantity are both big numbers, so we have to scale it back down. So we say divided by 1 ether, all right? Now, this is the expected stable out. Now we need to now do the slippage calculation based on this. So this is now uint 256 minimum token quantity out is what we previously just did, which is in short form, we can say expected stable token multiplied by slippage. Okay. and divided by, so because we're using 500, no, divided by 10,000 minus slippage. So this is going to be about 95% or something. Yeah, this checks out. Minimum token quantity. So that when we're doing the swap, and we're swapping this, the token in let me look at this function. Can I go there? Show me the definition. Let's go to the Uniswap itself. Swap router. Where is it? What's going on? This thing's acting so weird. I can't even go there anymore. It's so weird. Just take me there. So the function is called swap exact impute single. They seem to have changed the name to exact impute single, and it takes in all these fields. So we need to provide all these fields. So I was not wrong. But we just need to change the name to exact impute single. Okay, so we come back here. This function is so shockingly loaded. So it should be called swap router exact impute single. And if you recall, it swaps amount in of one tokens for another one, and then we need to provide all these fields. So let's just copy all these fields out. Let's go back. I don't need this one, so we can delete this one, but I do need this one, so I can comment it out. So I have token in, token out, amount. So the fee we're using, we typically use a fee of about 3,000. I reckon that's what's recommended, pool fee of 3,000. So we're going to do a pool fee of 3,000, yeah, which is if you divide it by 100, I think that's how it does it. I can confirm later. The recipient address, the recipient is obviously address the message.sender. Okay, so when we're doing the swap, we're liquidating to this. Okay, this contract deadline is just the current block timestamp. Maybe let's give it some leeway, plus 30 seconds, I guess. I think this throws me off a lot. Amount in, the token quantity in is going to be where is the token quantity in? This one, collateral token quantity. And amount out minimum is this minimum token quantity out that we just calculated, and this is equal to 0. What's the issue now? It says 7 arguments given but expected 1. So I need to do what I've previously done, which is I need to say something like, what's it called? iSwap router dots dot this. So problematic. And then this should have this. This should check out, I think. This should work. Then we don't need all this. Yeah. So we're passing in an object of this shape. It gives this amount out. So when we get the amount out, you know, it's pretty much done. Okay. So this is, wow, the complexity of what we just done. So I need to double check this and see if I have implemented it correctly, and I'll be see if there are any changes I need to make.